Hello and welcome to the channel. Today we're going to talk about electric sub-assemblies and specifically the tests that apply to electromagnetic compatibility of electric sub-assemblies that go inside vehicles. And when we talk about electronic equipment that goes into a vehicle, we would typically apply ISO standards against to conventional European norm standards that apply to residential environments and commercial environments and such. However, there is also one major legislation that applies universally, and that is UN 10 ECE. And that regulation applies in pretty much all countries worldwide, and UN 10 ECE requires that every electronic equipment that goes into a vehicle must comply with the requirements of electromagnetic compatibility. Whilst UN 10 ECE is published by Economic Commission for Europe, it applies pretty much globally, and it's requiring you to put an E-mark on your product, which has, at the time of recording this video, 48 regions where E-mark applies. And the list of the countries where e-marking is applied is displayed on the screen now. So you can see that this type of marking applies almost universally, and in order to get this marking, you must fill out the form and as well as provide the test report and product information with regards to what exactly your electric sub-assembly is. And then you send it to United Nations. You send a file, but not directly. You send it through your local government body. So, for example, in United Kingdom, we have Vehicle Control Authority. So when we affix an E-mark, we have to register with a Vehicle Control Authority, or VCA, before we can send the file, and then it will be logged into effectively the portfolio of compliant products. So let's take a look at the document itself. First of all, you can see that the regulation number 10 of the Economic Commission for Europe applies or concerns the provisions with regard to electromagnetic compatibility of vehicles. So that is pretty much the scope of this standard. It applies only to vehicles and vehicular environment. So then this kind of duplicated in the scope which considers the definitions of EMC and emissions and such and such. And finally, we get an definition of the ECA itself, which means that an electrical or electronic device intended to be a part of a vehicle together with any associated electrical connections and wiring. So that is effectively your FM radio or any kind of a Bluetooth transmitter. All of that will be considered as an ESA, as well as a kind of a vehicle driving assistant as well. And we'll come back into it a little bit later, because those have different categories of ECAs. So before we do that, we have this table here that provides a classification of ESAs, and basically you can do this flowchart to determine whether or not application of UN 10 is required. Pretty much if you do that, you'll see that for any active electronic device, the UN 10 will apply. Then following that, there's a description of the process and the application time, and then we get into the specification of immunity and non-immunity function. This is really quite critical because what it refers to is the function with regards to the operability of the vehicle itself. So if the electronic device goes out of service or electric sub-assembly stops working, does this cause a major problem to the vehicle to the point that it cannot continue driving? So if it does, then that would be considered as a critical or immunity function. And for example, if it's basically a steering assistant for the wheel, then you don't want that to stop working when you apply some sort of electromagnetic pulse. So if it does, then this can easily cause a vehicle to crash or have an accident. So this is a sort of thing that then will require application of immunity criteria during the testing towards the ER10. Whilst in other scenario, if it's just a Bluetooth transmitter or something like this, if this device stops working or is temporarily not functioning as it should be, that is not necessarily going to cause too much trouble to the driver unless it starts really disrupting the driver and creating loud noises, which is another reason for application of immunity function. So, for example, you can see in Table 1, application of transient phenomena to ESA would only be required if this ESA has immunity function. And then it has different performance criteria for different pulses. Those pulses are applied in accordance with ISO 7637-2, by the way. So, and then the different performance criteria which correspond to the normal criteria we use in EN 61000 standards, which basically go as A, no disruption to the device, B, some disruption to the device is visible, however it continues functioning during and after the test, whereas C means that the device requires a restart, but it restarts itself automatically and does not require basically any input from the operator. And finally, the performance criteria D is that the device needs to be manually restarted, so somebody has to press the on button, for example. Finally, you get the fail of the test when the device stops functioning completely and you can't even power it up again, and that would be considered as a failure even under UN10. But for non-immunity function, you will see that for all pulses the performance criteria is D. Moreover, the paragraph 6.10.3 tells us that ESAs with no immunity-related functions need not be tested for immunity to radiated disturbances and such. So basically, we would only apply transient immunity to such devices that don't require immunity function, and whilst we are applying transients, we are just going to monitor not going to monitor it even, we're just going to make sure that the device survives the test, and that's it. So we don't have to even monitor it, we just need to check that it powers on after the test, and if it does, that is considered as a pass. So very, very easy, you may consider that this sort of testing is not going to be the most difficult type of EMC testing, which is a bit surprising really, because typically EMC is quite present in vehicles, and there's a lot of different disturbances in the air, but for electric sub-assemblies that do not require immunity function, that is very easy to pass. Now, if we continue reading here, we'll still see that application of for intentional transmitters, the application of radio directive still applies, and so that means that they have to be tested for spurious emissions in accordance with ITU 329 regulation and such. Then also as a type of testing that will be applying under radio equipment directive that typically imply the application of ESE standards, and for example application of ESE 301-489-1, which then is going to call a lot more strict immunity testing than would apply to the ESA otherwise, so under UN10. So this is something you should be also aware of, is if your electronic device contains radio parts, then the radio equipment is going to take over, and UN10 testing, whilst is very easy to pass, is not going to be your biggest headache. Instead, you're going to have to pass all of the usual commercial environment tests for this sub-assembly, and that is going to be a lot more difficult than passing UN10. You can listen to my other video on this topic and get a lot more familiarity with radio equipment directive testing. Similar scenario, by the way, also applies in the United States, where you have FCC regulations, in particular FCC Part 15B, and that is a very similar story, whereas if you have an intentional transmitter, you have to do a lot more testing and get an FCC ID, so all of your testing has to be logged into FCC portal, and you have to display that. Anyway, moving on, we can also see that if a vehicle has an electric supply, for example, if it's an electric vehicle, you would have to also test it for harmonics, and there is a table 3 that specifies the maximum allowed harmonics as per EN 61000-3-2. That is quite standard test that would apply to all AC powered equipment in general anyway. Then following that, we also get finally some tables for conducted emissions on AC and DC power lines. So very typical for vehicle or environment for sub-assemblies to be powered from 24 volts rather than AC mains, because you don't have AC mains in the vehicle. And then you have to test for conducted emissions on 24 volt supply. That typically requires application of CISP 25 lesion. However, the UN10 ECE does not call for CISP 25 conducted emission limits. Instead, it calls, so the limits are specified in the table 10 for DC and table 9 for AC, as you can see here. And from table 9 and 10, you will find that those limits are in fact the typical class A limits that come from different types of standards, including ETSI 301-489-1. They have that standard has exactly the same table, and as well as very well known CISP 32 and EN 50432. So in other words, class A limits are sufficient, and there is no requirement for class B limits in a vehicle environment. That is a takeaway here. But the testing is obviously still required, and based on that you can probably guess that the application of radio emissions will also be necessary. However, in case of radio emissions, CISP R25 does apply. So for UN10 ECE testing, you would be testing CISP R25 emissions and not the EN55 or 32 emissions, unless you have a radio transmitter in your product, and then you actually have to test both, which is very exciting. So anyway, the CISP R25 method of testing is described in its own standard. However, you can see the table, appendix 6 rather than a table. These are the limits for radiated emissions in accordance with CISP R25. And the major difference with CISP R25 testing is that it's performed at 1 meter distance, and the antenna is directed at the cable rather than at the DUT. So it's basically looking at emissions radiating from the DC or AC cable rather than from the EUT itself. But because the DUT is never too far away, it typically also picks it up as well. But it's quite easy to actually pass this test, as we will be seeing it later. Then you would also notice that there are two types of limits. As usual with radiated emissions, there is a quasi-peak limit and there is average detector limit. So the two lines, and that is quite typical for all radiated emission testing. So the other important thing to mention is the methods of testing for radiated immunity when it actually applies. And as I said previously, it only applies to devices that have immunity function. Otherwise, you don't have to test at all. But if you do, then the application of ISO 11452 standard will be required. But there are different ways in which this standard can be applied and tested. So most typically is used in configuration A, ISO 11452-2, which is basically the typical anechoic chamber test, where you have an electric field with a strength of 30 volts per meter injected into DUT at 1 meter distance with various frequencies. So it's so the range is from 200 megahertz to 2 gigahertz, and there is also a very peculiar moment when you have to swap the position of the EUT, and instead of directing it at the cable, you will direct it at the EUT itself, and that happens at 1 gigahertz. So that's also something to be aware of, is that this testing is typically performed in an anechoic chamber, but there's no rotation of the DUT. And then if you apply ISO 11452-2, then there is no need to apply TEM cell testing, and there's no need to apply strip line testing. So this is basically one is excluding the other, but there is still need to apply bulk current injection testing in accordance with ISO 11452-4. And that is very similar to EN 61000-4-6, which is the standard conducted immunity test that you probably have seen me perform on this channel. And that is very similar to ISO 11452-4, except this time there's only a few tiny differences in terms of the current levels, the method of injecting this current. So otherwise it's also the same, and you're looking for the performance criteria A, obviously, in both tests for the. So you can see that for the immunity function device, it gets a lot more strict, because you have to pass very strict limits with regards to ISO 7637-2. You have to comply with performance criteria A for pulses 3A and 3B, and for load dump test you need to pass with the criteria C, and there is also another pulse which is similar to load dump pulse, which is a simulation of the engine cranking, and for that you also need to apply performance criteria C, so this is quite strict already. And then you have to also put it in anechoic chamber and do the immunity testing of 30 volts per meter in 1 meter distance, which is not far at all, so it's quite strict and easy to disrupt the device. And to finish it off, you put some current into the its DC supply and try to disrupt it even further. So that is effectively the test procedure that you have to follow for immunity testing to UN10 ECE of basically immunity function device. Finally, it's worth to mention that UN10 ECE also specifies testing for the entire vehicle for radiated emissions in accordance with CISPA 25, and this configuration is displayed in this picture here. That's how you would test for radiated emissions of a vehicle, which is not something that I'm going to do. I'm just going to use an electric sub-assembly only. So there's no test setup for this in my case. But there are other ways of doing the testing for vehicles, and typically to comply with UN10 requirements, as you can see, it's not really all that difficult. When a vehicle test applies and the radiated emissions is tested for the entire vehicle, rather than using CISPA 25, the Annex 4 will tell you that you have to use CISPA 12, which specifies the measurement of radiated broadband emissions from the vehicles, and that will have this type of basically test setup for motorbikes or vehicles shown here. So this is what would happen if you were to test an entire vehicle, but this is not what I am going to do in this series, so we're not going to worry about this. That's just for your information only. And finally, when all testing with respect to UN10 ECE is complete, then the manufacturer should fill out the form basically that is shown in Annex 2, and then send it to the Vehicle Control Authority or different authority in your country if it's not the UK, and then the E-mark will be issued, which looks like this, and this mark will be required for you to display on your product. It's worth also mentioning that if E-marking is not a requirement in your case, then you can also show the compliance with EN 50498 standard, which is effectively the same thing, but it's a European norm rather than international standards such as UN10. And if EN 5498 doesn't require you to go through all the paperwork exercises, instead it applies similarly to any other standard such as CISPA 32, for example, and you just provide test report and issue a declaration of conformity where you state that you basically comply with the requirements of EN 50498, and that's it. You don't mention UN10 in this case at all. So I hope this video made sense, and in future I will make more videos with respect to the specific testing for ISO standards and with regards to basically immunity function and non-immunity functioning ESAs. but for this video I just wanted to provide an overview of UN 10 regulation itself, and I hope you've been able to gain quite a lot of useful knowledge from this. Thank you for watching, and I'll see you in the next video really soon.